Okay, so let's do some easy stuff to start with. I want to talk about log base 2 of 8, right? What's the answer to this? Should be 3, right? One way I can think about that is to say, okay, this is a log base 2 of 2 cubed. And I could cancel the log base 2 and the 2, right? Another way I could think about this is I could use my third rule down there. And I could say, okay, this 2 should come off, or this 3, the power, should come off. That's really what this is doing, right? This is saying if I've got a log and a base of something to a power, I can take the power down front. Cool? Okay, so I can take the power down front. I could get 3 log base 2 of 2. Now it's log base 2 of 2. That's 1. You guys see that's an option for this? Okay, so let's try.
But would the answer be 3? Is it 3 times 1?
Oh, sorry. Thank you. 3 times 1 is 3. Good call. Okay, let's try another one. So if I was to do log base 2 of 8 times 4. One way I could do this is I could count all the 2's in there, right? Another way I could do this is I could apply my first rule. Yeah?
Would it be bad to multiply the 8 and 4 together?
No, not at all. That would be a definite way to do this. That would be alternate to the one I'm doing.
We do that next?
You get the same number.
You do?
Yep. Let's do it this way first, then we'll do it that way. Basically to check that these rules are working, right?
So we're not changing it.
Ah,
We are next.
we're going to do that next. So right now I'm going to apply the first rule. And it's going to tell me that this is log base 2 of what?
2 times 2 or 2.
Let me do the first rule. So log base 2 of 8 plus log base 2 of 4. Is cool then? Now these are things I know about. This is log base 2 of 2 cubed plus log base 2 of 2 squared. So I get 3 plus 2 is 5. That's cool then? Okay. If I did it the other way, I could say this is log base 2 of 32, right? Which is log base 2 of 2 to the 5th. So I get 5. Cool.
And what other rule is that?
So this is just canceling of logs, right? This is the log base 2 and raising things to the 2 undo one another. In this other rule, I use just a first rule, right? The log of a product is the sum of the logs. In fact, actually, we should probably write those down. So let me tell you that this guy, if I'm going to say this, I'm going to say the log of a product is the sum of the logs. That's that first rule. How would I say the second rule? The log of a, it's a fancy rule for it's a fancy rule for fraction, quotient, right? So I could say this one as the log of a quotient, or the log of a fraction, right, is the difference of the logs. And then if I was to say this one, I would say powers drop down front. Right, so really, log of powers drops down front. Cool with that? This last one I'm actually going to use quite a bit. These other two I'll use kind of less often, but still frequently. This last one is going to be the thing that's really useful. What's that?
So that example like you did up there, if you did, go back to the up one, the top part, right there. So if you did log 2 to the 2 to the third to the x, but did the 3 to the x drop to the front?
Yeah. So that's a great example. Let's do that one. So another example might be, all right, I've got log base 2 of 2 to the 3 to the x, right? One of our little towers of powers. And now I say, okay, I want to use my rule. So this stuff is the power, right? That stuff drops down front. Cool then? So I get 3x log base 2 of 2 is
3x.
3x. Cool. That's it.
It looks so easy.
Second one? You want to try that one? Okay, let's try the second one. So, if we want to do something like log base 10 of
Oh.
2,000 over 5, there are going to be parts of this I'm not going to get to evaluate. Okay? Life is not always easy. A little bit like square roots, right? Sometimes when I write down the square root of a number, I can simplify that. Sometimes I can't. So, just like square roots, sometimes we'll be able to write down the log of a number and simplify it. Sometimes we won't. Cool. All right, so let's try it. So let's see. This would be, I'm doing log base 10 of 2,000 over 5. So I could simplify this a little bit to start with, right? Log base 10 of 400, right? Okay, let me do it this way, and then we'll talk about the other way too. So this would be so log base 10 of 2,000 minus log base 10 of 5. Okay. So what? Oh yeah. 2,000 is 2 times 1,000, right? You guys see that? I'm still subtracting log base 10 of 5. So then what might I apply? I have a log of a product, right? So I have a rule about logs of products. You guys see that? So I might apply that. I might say, okay, this is log, oops, forgot a base 10 there. Log base 10 of 2 plus log base 10 of 1,000.
And can you say that 5 is 10 divided by 2?
We can. So this is minus log base 10 of, you guys see what she wanted to do? She wanted to say it's 10 over 2, right? You guys see that? Why did she want to say it's 10 over 2?
So it's gonna match with the other stuff?
Yeah, because there's a log base 10, right? She wants to introduce as many 10s as she can so she can simplify them all. She's going to pay a price for that, right? So, just like anything, you're not going to get anything for free in these. Sometimes you're going to have to pay a little price. On that one, we're going to end up with a log base 10 of 2 left over someplace. So let's see, I've got a log base 10 of 2. I don't know what to do with that piece. Does that make sense? Right? I don't know what I raised 10 to get 2. It's some kind of horrible decimal. Right? It's an irrational number. Crap. I'm just going to have to leave it like that. That thing's a little bit like square root of 2, right? I don't know how to evaluate it, so I'll just leave it like that. Then I've got plus, what's the log base 10 of 1,000? 3? Does that make sense that it's 3? 10 times 10 times 10 is 1,000. Right? 10 cubed. So I get 3. Seems a little out of place, right? And then I've got minus. Can I evaluate log base 10 of 10 over 2?
Yeah. Log base 10. And then
End up with 1/2.
or minus.
Yeah, so don't do 10 to the 1/2 because 10 over 2 and 10 to the 1/2 power are different things, right? Does that make sense?
Don't you?
10 to the 1/2 is the square root of 10, which is a bit bigger than 3, right? 10 over 2 is like actually 5. You guys see that? So those aren't the same, so I can't do anything with that. But I can apply my second rule and get log base 10 of 10 minus log base 10 of 2. You guys see that I had to throw some parentheses in there because I meant to subtract that whole thing? So I could distribute a little bit. I could get log base 10 of 2 plus 3 minus 1 plus minus is plus. What am I getting? Log base 10 of 2. You guys see that?
So 3 minus log base 10, 10?
So I've got 3 minus 1 is 2, right? I need some more space.
Jerry, why wouldn't that all be in parentheses still? Because you're still subtracting.
I distributed the negative 1 through. So I did minus log base 10 plus log base 10 of 2.
Yeah.
So if I bring this guy up here, I've got, this is log base 10 of 2 plus 2 plus log base 10 of 2. How many log base 10 of 2's are there?
2.
It's 2 of them. So I could rewrite as 2 log base 10 of 2 plus 2. You guys see that? This was a long way, but this is done. This is as simple as this thing's going to get. The only other thing we could do, does anybody see it? How could I get a 4 in here?
Log base 10, 2 squared.
You guys see that?
Oh,
We're using the last rule to say, okay, I've got a number times a log. I could bring that in as a power. That's the opposite way, right? This is the power drops down, right? This is you could suck it up, right? So we could grab that 2 and put it up here as a power. So we could get log base 10 of 4 plus 2.
Do we have to do that?
No. So either one of these is fine. If you divided the 5 into the 2000 first, you were looking at log base 10 of 400, you would get to this one. Yeah, see that? You'd get the log base 10 of 100, that's 2, added to the log base 10 of 4. You kind of see that? Okay, so if we had done that the other way, we'd get log base 10 of 4 times 100, right? That's what 400 means. And then we could use our first rule to split it up into log base 10 of 4 plus log base 10 of 100. This thing's 200, or 2 10s multiplied together, right? So I get like 2 out of that piece, and then there's my log base 10 of 4. Gets you the same thing. It's going to be a bit confusing sometimes, right? Like if we had left that 5 in there, we would have had a really confusing way to express 2 things. You guys see this? So don't assume, and these are very critical, don't assume that the answer in the back of the book was achieved in exactly the same way as yours. So it might look pretty darn different. Another way we could have gotten this, so let's see, we've got this one, this one. There was one more back here. If we had left this as log base 10 of 5, we could have gotten log base 10 of 2 plus 3 plus log base 10 of 5.
Do they all come back to the same answer?
They're all the same number, yeah. So I'm fine with any of these 3 from you guys. Cool that? The back of the book will pick one of these, right? These 2 are just a log rule apart, right? But this one is a couple of log rules away from being one of these guys. You guys see that? Oh, and that should have been a minus. Cool? So careful with the log rules. They do get a little bit confusing. Cool? All right. Awesome. All 3 are the same. The last one? This one? It's the same. It's the trick that you noticed about this, writing 5 as 10 over 2 and then doing all that jazz. It's that away from being the same thing. Cool. This is where I would have stopped there, but you noticed the 10 over 2 thing, which was cool, so we did it. Cool? These get confusing, and the answer in the back of the book is not going to be the same as the one you get, oftentimes, even though they're right. So if the answer looks different, what do?
Ignore the back of the book.
Either have some confidence, right, and ignore the back of the book, or get out your log rules and start making them the same. It's going to take a while sometimes.
I'm done with them.
Cool? But it's good practice with log rules. Cool? All right, I want to talk about one more thing because I don't have enough time to give you a quiz. So, the thing I would like to talk about is some standard notation. Okay, so this is just symbols that we've made mean specific things. Okay? So we have these symbols.
Yeah, I didn't ask about that.
Okay? So these symbols are in your book, and they all mean a logarithm, right? This one on the left is,
Then an L.
it's just an ln. So this is called the natural logarithm.